Hey Joel, so this is section 8.1, and you start with kind of the unit circle. So we have a circle, radius 1, and if we draw a triangle in there, so this is our radius, so we can draw a triangle to the x-axis. So this is our length x, and this is our length y over on this side. And so you can kind of see it's just a right triangle, so Pythagorean theorem holds true. So we'll have x squared plus y squared equals r squared. And so then our first three trig functions based off of this are sine theta, cosine theta, and tangent theta. So sine theta is going to be, and all of these are just ratios of these sides. So sine theta is y over r, and cosine theta is x over r, and then tangent theta is y over x. And then with that, notice that tangent theta is actually the slope. It's the rise over the run, so it's the slope of the tangent line. So if the radius is 1, then what this gives you, y would be the actual length of this side of the triangle, x would be the actual length of this side of the triangle relative to radius 1. So that's what sine and cosine are. And again, tangent is slope. So then the reciprocal functions that go with this are cosecant theta, and so it's the upside down of sine, so it's r over y, and it's also 1 over sine theta. Cosine goes with secant theta, so that one is r over x, and that is 1 over cos theta. And then tangent goes with cotangent, and that one is x over y, or 1 over tangent. There's a sheet of notes that has all these properties on there, and you will get that for the test. So I'll post that on the site. So this is kind of what we have to work with, and then let me show you some problems. So the first one I was going to do is number 2 off of, I'm not sure what page, 236. So number 2 is asking for, what's giving us this set of coordinates. Actually, let me start a new piece of paper. So we have a set of coordinates -4.00 and 12.0. And the directions are the terminal side of an angle is in standard position, passes through the given point. Sketch the angle, compute the distance r from the origin to the point, and then write the 6 trigonometric functions of the angle. And work to 3 sig figs. So let me show you what that will look like. So if I sketch this, x is -4, so it'd be 1, 2, 3, 4 this way, and y is 12. So you can figure it's about 3 times as tall as it is here, so I'll just kind of do an approximate. But so it looks something like that. That shouldn't be an arrow, that should be a point. And so we're trying to find sine, cosine, tangent, and then the cofunctions that go with those. Or actually, sorry, the inverse functions that go with those. And sorry, there's some construction that's happening, so you'll hear construction sounds now and again in the video. So what we know is x and we know y. And so to find r, we just do x squared plus y squared equals r squared. So that's -4 quantity squared plus 12 squared equals r squared. So that's going to be 16 plus 144. And let's see, that comes out to 160. And then if you turn that into a decimal, it's about 12.6 is r. Okay, hopefully the sanding has stopped. So back to finding the 6 trig functions. So sine theta is going to equal y over r again. So y was 12. And r is 12.6. I should probably be using root 160 just so there isn't the rounding error until the end. and then divide that, and I got 0.952. And then for cosine theta, that one is x over r. So x is -4, or 12.6. And that one comes out to -0.317. And then tangent theta is y over x. So that would be 12 over -4, or -3. So then to find the cofunctions, so you can either do, you can either just flip the fraction. So I'll just do cotangent because it's easy. Cotangent theta, I can think of it as x over y. So that would be -4 over 12, or -1/3. But remember that cotangent could be x over y or 1 over tangent. So I could have also just taken this answer and said cotangent theta is 1 over tangent theta, so that's -1/3 again, because that's our -3 down there. And so these you could just do 1 over this decimal, and then, or you could flip the x and the y. Okay, number 8 is just finding the sine, cosine, and tangent of a given angle. And so number 8, they give us 216. And all this problem is figuring out how to use your calculator. So sine of 216, if you plug that in, should come out to -0.5878. Cosine should be -0.8090. And tangent is 7265. And so if you're not getting those numbers, it means your calculator's in radians and you need to switch it to degrees. And that's pretty much the point of this problem, is to just kind of show you how to plug them in and make sure that you know degrees versus radians. And radians we'll learn about in a couple of sections from here. From there, we're going to number 20. And actually, I can do that right here. So number 20 is evaluate to 4 decimal places, and we're supposed to find cotangent theta if tangent theta equals 1.4638. And so to do that, we'll just do cotangent theta equals 1 over tangent theta. So I can just plug that right in here, and then chunk that in the calculator, and I got 0.6832. 22, same thing. So we're finding secant. Oh, sorry, not the same thing. We're finding secant of 158.3 degrees. So that is the same thing. So secant back here goes with 1 over cosine. So I can say 1 over, because we don't have a secant button is the problem, so I can go 1 over cosine of 158.3 degrees, because secant theta equals 1 over cosine theta. So I can just plug the theta into cosine. That I can plug in the calculator. And then for that one, I got -1.0763. Okay, and then the last bit is something called cofunctions. And the properties for that are two angles are cofunctions where two functions are going to be cofunctions where a plus b equals 90 degrees. So if I have sine of a, it's the same thing as cosine of the other part of the angle to bring it up to 90, cosine of b. And the reason for that, I'll go back to this thing. If we think of, if I have a 30 degree, this goes 1, 2, square root 3 for 30 degrees. You'll need to know that just using it as for this example. And then for 60, it's the same triangle, but now, so the radius is still 2, but the tall side is the root 3, and then the short side is the 1. And so if I go cosine of this one. So cosine of, or sorry, let me go sine of this one just so it's in the order that I just wrote. So if I say sine of 30, that is going to be y over r, which is 1/2. So over here, if I go cosine of 60, because that's 30 and 60 make 90, it's going to be x over r, which is still 1/2. So that's what the cofunctions are saying, is that these two angles are going to have the same value when you do sine of one and cosine of the other. And so the rest of those relationships are tangent and cotangent. So tangent A equals cotangent B, and then secant A equals cosecant B. So these are sine, cosine, tangent, cotangent, secant, cosecant. And so it's the cofunctions that they're named for, not the reciprocals, which is always confusing. And then the reverse of these is also true, so that means that I could also say cosine of A equals sine of B. You know, we can write the A and the B either order, and same here and here. So these last couple of problems, 28, we have sine of 38. So we're supposed to express the function as a complementary angle. And so if I have sine of 38 degrees, then that means I'm going to have cosine of 90 minus 38 degrees, because we need what I would add to 38 to make 90. So I'm just taking 38 away from 90. So that will be cosine of 52 degrees. So these will have the same value. And last one is 32. This one is cotangent of 63.2. And so for that, that's going to have the same value as tangent of whatever would fill this up to 90. So we'll just say 90 minus 63.2, and that would be tangent of 26.8 degrees. And that wraps up 8.1.